minimization problem. Now, let us see how to solve this problem using branch and bound. Now, so I'm going to generate a state space tree, and here I'll be using LCBB. What do you mean by LCBB? Least cost branch and bound method. So in the previous video of branch and bound, we discussed about there are three different strategies to generate a state space tree in branch and bound algorithm. So the first is what? FIFO method. The next is LIFO method. The next is least cost method. So we can take all these three, but I'm going to take least cost one. The reason why I'm taking least cost is it is what the fastest method. It is what the fastest method. That's what I'm going to take. If you have a question in the examination, then to take FIFO and to solve 0 by 1 knapsack problem, yes, you can do it. If you have a question with LIFO, that also you can do it. And that is the reason in the previous video of branch and bound, we were taken one problem and solved with these three techniques. So you can follow that algorithm techniques to apply over here to find the solution. Now, least cost branch and bound is what? I will be exploring that node whose cost is minimum for solving it using branch and bound. For each node in a state space tree, we have to find out upper bound and cost. So we define it as sum of all of the profits. Now the solution for this problem can be written in variable size solution, fixed size solution. Variable size solution in the sense that which are objects I placed in the bag. That means let us see, x1 and x3 is my solution. Then fixed size solution is what? 1, 0, 1, 0. So whichever object is placed in the bag, for that object we'll place it as 1. So this is going to be our solutions. You can use variable size or else you can use fixed size. Now, so I'm going to take sets method. That is what fixed size method, fixed size solution. Now I'm going to solve this problem in this form of solution using LC branch and bound. Now let's go ahead. So now what I'm going to do is will come from the starting. Now, so I'm going to generate a state space tree. Initially you have to calculate the cost function, and you should also know what is the capacity of the bag after placing each item inside of the bag. Now, so make it is a upper value first of all. Upper value is infinite. So find out the upper value. How can I find out the upper value? So this is the formula to find out the upper value. What is the formula? Summation of I is equal to 1 to n pixi less than or equal to m. So find out the u value. U value is what? Profit and object. So now profits is 10 plus 10 plus 12. Now it is what? 18. So 10 plus 10 plus 12 plus 18 is what? It becomes 20, 32, 18. 50 is the weight, right? Now listen carefully. If I calculate the cost of it, okay, now cost is what? Pixi. 10 plus 10 plus 12. If I take in this way, this 10 plus 10 is the profit for which item? X1. Now what is the weight of it? 2. This 10 weight is 4. This 12 weight is what? 6. Now let us assume that I have a knapsack. 6 plus 4 plus 10 plus 12. 12 kgs are I have used with this x1, x2, x3. Now how can I place the total total object inside of the bag? I cannot, right? Because I don't have a space. I have only 3 kgs of weight to be used. So but here the fourth item is having 9 kgs of weight. So among this 9 kgs I can take only 3. So that's what cost function I'm going to take with the fraction. And this u upper limit is I'm not taking with fraction. So let's go ahead. Now if you take out this value from this, now 18 by 9 into 3, that means 6. So 32 plus 6 will become 38. I told you in the beginning slide, in the previous slide, that the this values has to be changed, sign should be changed from positive to negative. So now the upper value I am taking with minus 32. This figure you have to take. Why this figure you have to take? Because I am not taking u value with the fraction. So without fraction is what? 10 plus 10 plus 12. That is 32. And c value is what? With the fraction. That's what it is, 38. Now I am going to generate the state space tree. Let us suppose that I am placing the first object. Initially, what the cost you got? Cost is minus 38 with fraction, and upper limit is minus 32 without fraction. Now, when I place x1 object, the same. If I don't place x2, x1, it is second node, it is third node. Assume that I am not placing x1. That means x1 equal to 0. So in the place of x1 is equal to 1, the same cost and the same upper limit will be there. Minus 38, u is equal to minus 32. Now let's see. If I don't place x1 value, then what happens? In both u and in c, you have to take out the 10. So that means if I cut this 10 over here, because S1 object 10 has not included, and this 2 also not included. Now let us calculate the cost and upper limit. So now C is equal to what? X2 object, X3 object. 6 plus 4 is 10. Still you have only 5 more kgs left. So when you have 5 more kgs left, what you will do? Now that means you will take this 10 plus 12. Now this time 18 by 9 into 5, because 5 kgs only we can use. So it is what? 10 plus 12, 22. 5 into 2 is 10. 22 plus 10 is what? 32. 22 is u value. Correct? 22 is u value. C value with the fraction you can take. That is what? Minus 32. Okay. Now let us have x2 object inside of the bag. So there won't be any change. The same value, c is equal to minus 38, u is equal to minus 32. If you will not place x2, then let's see the value of u and c's. So x2 is 0. x2 is 0 means what? x2 means this 10 will get out of the picture. That means this 10, this 12 will be there. 10 plus 12 is what? 22. Now, how much weight I can still keep inside of the bag? That let's see. This 10 is there, but this 10 is not there. So that means 10 plus 12 is 22. And come here. This 4 is not there. 2 plus 6 is there. 2 plus 6 is what? 8. Still how much weight I can use? 7. That means 8 by 7. 18 by 7. U is equal to, for the value x3 is equal to, x2 is equal to 0. x2 is equal to 0. U value is what? U value is 10 plus, and this 10 you will not take because x2 is not there. 10 plus 12 plus 18 by 9 into 7. So the cost is what? 10 plus 12 is 22. 22 plus 7 into 4 is 14. 22 plus 14, it becomes 36. Now, when x2 is equal to 0, your u value is minus 32, c value is minus 36. So, c is with fraction, u is without fraction. So, I am calculating in one equation. So it is what, if you consider this fraction, then it is C value. If you don't consider this, it is U value. Please keep in mind. Now let's go ahead. So here you got x2 equal to 0. Now let's see for x3 is equal to 1. If x3 is equal to 1, then the cost value you please calculate. Then what is the value if x3 is equal to 0? U is equal to minus 32, C is equal to minus 38. Now if I don't place x3 value, that means x3 is equal to 0, then what is the value? That if x3 is equal to 0, U value is minus 38 and C value is minus 38. Now let's see that when I wanted to explore the node according to least case branch and bound, I have to take least cost, correct? So now I am taking the least cost method. So among these two, minus 38 is the least cost, right? So now I am going to take this minus 38, this minus 38. That means from fourth node exploration will get started. Now the reason I have to update even minus 32 to minus 38 because I got a least number than that, correct? So now here x1 equal to 0, first object is not included in the bag and the cost is minus 32. So this is what minus 38 is the least one, right, than minus 32. So I am using bounding function to get it because I found a cost which is lesser of this. So this cost is greater of the node. So I have to bound it. That means I have to kill this node. The same minus 36. I will be killing this node. So finally I have this minus 38 and this minus 38. So among these two, what I have to place? Now let's think. x3 item, x2 item, x1 item, both items we were placed in the bag. That means 6 plus 4 plus 2, which will give weight of 12. So if I do not place which item? x3 item if I do not place, that means this item. Then 9 plus 2 is what? 11. 11 plus 4 is 15. So it is what? The perfect solution. That means x3, without x3 it is a perfect solution. So we will explore this node to say it is an infeasible solution and we start exploring this node. So in this node, can I have x4 object? That means x4 equal to 1, x4 equal to 0. Now let's see. So when I put x4 equal to 1, then what the value you will get? x4 equal to 1. Now calculate your C and U. So U is what? x4 is equal to 1. That means 10 plus 10 plus 18. Now what is the value? 20 plus 18, which is 38 when x4 equal to 1. That means C is equal to U is equal to 38 minus 38. What is the C? So if you see the profits, if you see the weights of it, you will be finding out perfectly whether it is gives you the what the cost it will give you. That is what? 2 plus 4 plus. So third object I am not including. That's what? x3 is not included. x4 I have to include. So 12 is not required. 2 plus 4 plus 9. So how much weight is still left? 9 plus 2, 14. Exact weight. So you cannot have any fractional part over here. The both are equal. Minus 38, minus 38. Now let's see. If x4 is equal to 0, the cost will be minus 20. So it is what? The more cost, right? It is maximum than minus 38. So that's what? This is the final solution. What is the final solution? That x1 you can place, x2 you can place, x3 will not, and x4 is. That means the solution is what? S is equal to 1 comma, that means x1 object is in the bag, x2 object is in the bag, x3 is not, x4 is in the bag. That's what we were shown with the sets method. 1 1 0 1. Now that final cost of the bag is what? 10 plus 10 plus 0 plus 18, which is 38. It is a maximum value, right? 2 plus 4 plus 9, it is a maximum capacity what we were used. So these are what the respective U and C values to each node what we were solved in the previous slide. So this is what knapsack problem using branch and bound. Thank you all.